Okay, this is probably the single ugliest periodic table. It's hard to see some of it, matter of fact, right? Can you see that? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? And then this is going to be 1, 2, 3, 4, 5, 6, 7, okay? And these are 6 and 7 as well, okay? This is 4F, 5F, okay, we set? Yes? Yes? This is the noble gases here, 18, it's helium, neon, argon, etc. Yes? Correct? Okay, now the question is going to be, what is electronegativity? Well, electronegativity is a number that, relatively speaking, indicates a certain electronegativity strength. It really means nothing by itself. Yes?
Okay. Electronegativity is the ability of the atom to attract more electrons?
Close. Attract what kind of electrons?
In a covalent bond.
Yeah, bonded electrons. Yeah, it's a tendency of an atom, an element, to attract bonded electrons. Okay? For instance, if you have, let's see where I can write. Let's say I have fluorine. Okay? Let's say I have fluorine. Okay? All right. Now, fluorine needs how many electrons to be like the nearest noble gas? Here's fluorine. Correct? Now, remember, we spoke about atomic radius. Remember? Remember atomic radius? And we spoke about ion radius. Correct? Now, what was significant about the atomic radius of the group 17 elements relative to the rest of each in that row, each in that period? For instance, let me rephrase that. What was the significance of the atomic radius of fluorine relative to the rest of the elements in that period? Yes?
It's bigger.
Of the atomic radius. Remember? Let's do this. Let's do this. Let's put them all here. 1, 2, 3, 4, 5, 6, 7. Okay? This is going to be 3, 4, 5, 6, 7. Sorry, what did I say? I'm like counting and I started with 3. Well, I wanted to start with 3, I suppose. Right, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So what are these numbers that I have written down? What are the numbers? I was getting myself confused. What are those numbers? What are those numbers? Those are the nuclear charge, right? Nuclear charge. So we're going to say, I'm going to erase this right here, and we're going to say this is the atomic number, or we're also going to say it's the nuclear charge, right? Isn't that correct? Yes? Okay. Now, we're going to say, I'm going to erase this. We don't need the whole periodic table anyway, I suppose. But we can use portions of it. Okay? So, let's say, what's going to be the valence shell for each of those elements, for each of those atoms? What's going to be the valence shell? What's going to be the outer shell? 2. Okay? 2, 2, 2, 2, 2, 2, 2, 2, right? That's going to be the valence shell, right? Correct? Yes? That's going to be the valence shell. Right? Okay? Now, let's say that let's put the number of electrons in, shall we? Number of electrons. 3, 4, 5, 6, 7, 8, 9, 10. Okay, those are the number of electrons, correct? Okay, now, as I add these electrons, am I increasing the number of rings? Am I increasing the number of shells around the nucleus? No, it's all the same, it's 2. So they're all going on 2, correct?
Yep.
All right, now. So that ring is getting full, correct? But am I increasing the shielding effect? Am I increasing the number of electrons between that valence shell and the nucleus? No, I'm not. Correct? So do you see what's happening to the distance between the valence shell and the nucleus as I increase the nuclear charge? It's getting smaller. It's collapsing in on itself. Like it's a sun becoming a black hole. It's collapsing in on itself, isn't it? Right? So that, which one's going to be larger? Lithium or neon?
Lithium.
Somebody said neon. Why neon? I don't care who said it. So don't look around like with great guilt. I don't care who said it. But why would it be lithium? Defend it, yes.
Because the protons bring all the atoms closer, and the more protons there are, the closer they bring all of the electrons, I'm sorry.
Right, so is lithium larger or smaller?
Larger.
Larger. Why would it be larger?
Because
You just told me why neon might be smaller, but why would lithium be larger?
Its pulling force isn't as great as neon.
Lauren?
because it's, like Johnny said, its force isn't as great as neon, so the electrons are still kind of like that.
Yes, it's just like Ringo said, that the nuclear charge is smaller. Smaller. There's not that great of an attraction between the ring and the nucleus. So it's kind of bulging out a little bit, isn't it? But if I increase that nuclear charge, look what I'm doing. I am collapsing that ring, right? So look at fluorine here. Look at fluorine. These don't have a electronegativity. Well, these do a little bit, I suppose. These can form elements, but it's really these we're talking about, isn't it? Okay. So fluorine has an electronegativity of 4. Okay. And so why would that be the greatest electronegativity? Why would that element in a bond attract the electrons to the greatest degree? Yes? Because it has more protons, right. But where would the bonding site be? Where's the bonding site? Is it close to the nucleus or far away from the nucleus? Where's the bonding site? I'm going to erase the periodic table. I think I've made my point with the periodic table. So where's the bonding site for the fluorine? It's close to the nucleus, isn't it? So what bonding site is closer to the nucleus? Fluorine or...
Lithium?
No, lithium's, all right, let's say lithium, or lithium. What's closer to the nucleus?
Fluorine.
Fluorine is close to the nucleus, right? What has a greater draw on that electron? A greater attraction for that electron? Okay, fluorine. How many electrons does fluorine need to be like neon? One. How many does lithium need? It needs 7. Is it gonna take on 7, or is it gonna give up like 1 to be like helium? It's gonna give up 1, right? So does it really have an attraction for any electrons, lithium? No. Does fluorine? Fluorine has 2 attractions. Attraction number 1. The bonding site is very close to the nucleus, isn't it? Yes? And number 2, it's what? It's like going to be like neon, right? So what's going to have a larger electronegativity? Fluorine is going to be very large. Okay, chlorine is going to be close. I think chlorine is 3.5. Is that what it says? Does it have a table of electronegativities? I don't see one. But if you look it up, I think chlorine is 3.5. Yeah, you should have one in your thing. Try to find one there, Porcium. Find a table on electronegativity. Right? Now, look at francium. Look at down in the other corner. Francium. What has francium cesium? What has the lowest electronegativity? What has the smallest electronegativity? Francium, right? Yeah, do you see that? Bottom left. So what happens is, here's the periodic table, right? That's the periodic table. So here, where you have a noble gases and you have an element that's just 1 electron away from being like a noble gas, that's going to have a large electronegativity. And as I go this way, it gets smaller. Francium is enormous, absolutely enormous. Radioactive, by the way, and just very enormous. Correct? Very enormous. Yes? And it doesn't really want 7 electrons. It wants to get rid of the one it has, doesn't it? Okay? So why, though, does it go diagonally? Why does it go diagonally?
Because the electronegativity increases from...
No, I know that, but why is the highest electronegativity here in this region and the lowest in this region? Why does the reduction in the electronegativity seem to go diagonally? Yes?
Because it's also easier for the larger atoms to lose electrons, since the inner electrons are repelling the outer.
Right. This needs to give up 1, sodium, this whole column, right? But look at lithium. Isn't lithium closer to the nucleus? Look at the ionization energy of lithium versus francium. What has a larger electronegativity, lithium or francium? What has a larger ionization energy? Lithium does. Lithium does, right? So that's more tightly held, isn't it? So that's going to have a little bit higher of electronegativity, isn't it? Yes? Yes? Okay. Now, there is kind of like an exception, which we'll talk about when we talk about other things. Hydrogen, also, why isn't hydrogen like 4? Why isn't it 4? Well, it has a really small nuclear charge. That's one of the big things about hydrogen. It has a very small nuclear charge. So it doesn't really, I mean, fluorine's nuclear charge is 9 times that of hydrogen. And the distance is not 9 times, you know. The distance between the second shell and the first shell isn't 9 times that between the second and third shell. So anyway, so it's a combination of how many electrons it needs and distance from the nucleus. That's why you get that sort of two-dimensional thing. It's going down because as you increase the atomic radius, right, you're decreasing the electronegativity as you go down, right? And as I go over, you're increasing the desire to even take on electrons, aren't you? Because, for instance, aluminum wants to give up 3. It doesn't want to take on 5. So the reason it goes diagonally is because you have 2 reasons why electronegativity exists at all. It's proximity to the noble gas and atomic radius. Why atomic radius? Bonding site. Correct? You get it? Now what's electron affinity? What is that? What is electron affinity? Gotta know this, guys.
Is it the energy change when the atom give out electron or taking electron?
Okay, I gotta know specifically. I need you to tell me as if you discovered the concept. Anybody? Yes. Ling Ling.
It's the energy change that occurs when 1 mole of electron is added to 1 mole of gaseous atoms.
I can't hear a word you say. Ling Ling, you might have been correct, but somehow I don't think when you're playing a sport or something, you're that quiet. Okay? You want to shout that answer? Pretend you're at Yankee Stadium, which you probably have no idea what that even means. But why don't you try that? Try that again.
It's the energy change that occurs when 1 mole of electrons is added to 1 mole of gaseous atoms.
Okay. It's the energy change. Could anybody want to help me out here?
It's the energy change when 1 mole of electrons
Is added to 1 mole of electrons is added to
1 mole of gaseous
1 mole of
atoms.
1 mole of gaseous atoms. So what does that mean?
It becomes a mole of gaseous ions.
It becomes a mole.
It becomes a negative ion.
It becomes negative ions. Is that what it says?
Should, since it's gaining electrons.
When 1 mole, okay, 1 mole, so let's say 1 mole of oxygen, right? 1 mole of gaseous oxygen, is that what you're suggesting? 1 mole of gaseous oxygen. Okay. Why on that page does it say O to the negative 1? Why does that say that? See, it says right there on page 106. Why does it say that? Why is it this? O plus
Because the oxygen is gaining an electron.
because what?
It's gaining an electron, another electron, so then this negative recharge increase.
It's gaining 1 electron. Okay, I see that, but why isn't it just O, ground state? Because
It's a negative ion. Well,
Yeah.
it's a negative.
Maybe that, yeah, maybe the oxygen is already a negative ion.
I'm lost. I don't understand.
The one with X is a
I want you to explain this to me like I have no idea what I'm doing.
Maybe O isn't the best example to use. Just the one above.
Because I see the one above it, it says X G plus 1 E negative yields X negative 1 G. Is that correct?
Yep.
I can deal with that. That makes sense. But why are they using an ion?
Maybe you just want to show that the same thing happens, like the same robust ions.
Yes.
I'm probably wrong here, but doesn't oxygen usually bond in pairs and thus form a bond? I don't know. Negative is, the bond is negative.
So you're suggesting that oxygen bonds in pairs. All right, let's see what that looks like. I like that. That I can deal with that. I'm not sure I like it. I'm not sure it's right. I'm not saying it's right or wrong, but let's say. So oxygen has, what's the valence of oxygen? 6, right? Yes? Okay. So it has 6. So you're saying that I have an extra electron, so it's -1, right? I'm gaining 1 mole of electrons, and I'm getting this. Right? Right? And then I have that as a -2. I'm not sure, does that tell me anything, or where are my other electron affinity people? Anybody? Okay? No? Okay, now, we're going to do electron affinity and electronegativity together. This is part 1. Part 2 we'll do next class, okay? Yes? And then we're going to tie it to bonding. Clear? And then, don't pack up, and then we're going to start bonding. Understood? Now, let me end this, and I want to show you what to do. I want to tell you what to do to help you for next week. Clear? Okay.